Hello, good afternoon class. We hope you are doing well. Today's lecture will be about the optical telescope. Our names are Alejandra Santos and Diana Perret. To initiate our lecture, we will watch a short video about the history of the optical telescope. Enjoy!
Welcome to the Canada Science and Technology Museum in Ottawa, Ontario, in our Mega Science exhibition. Hi, my name is Michel. I'm an educator here at the museum, and I'd like to talk to you about telescopes. The beginning of modern astronomy is often linked to Galileo building his first telescope in 1609, roughly 400 years ago. While he was not the first person to use telescopes, Galileo made several important discoveries, notably craters and mountains on the moon, spots on the sun, and other moons circling planet Jupiter.
Ultimately, his observations revealed that the Earth orbits the Sun, which was revolutionary in a time when people firmly believed the theory that the Sun, the Moon, and the stars all orbited around the Earth.
When astronomers started looking at stars, they had only one tool to answer their questions: the optical telescope. One must keep in mind that the electromagnetic spectrum contains quite a lot more than visible light. These include your radio waves, microwaves, infrared, ultraviolet, X-ray, and gamma ray. This led the scientific community to identify manners in which they can view the night sky, not only depending on visible light, yet defying the odds and using the other spectrums which are available for us. Thankfully, the scientific community was able to create the radio telescope, which creates images of objects which cannot be seen with visible light. Instead, these telescopes receive signals from radio waves. This is an image of Jupiter being compared from a radio telescope and an optical telescope. In addition, these telescopes are quite similar to the radios in your cars. However, they are quite more larger and they are found in rural areas. In addition, they are quite sensitive and are composed of a mesh. On the other hand, your optical telescopes include two types: your reflecting and refracting telescopes. They are utilized for visible light astronomy. Refracting telescopes tend to be quite more smaller than reflecting telescopes. Refracting telescopes use two lenses that focus light into the eye. Considering the lenses flip the image once and flip it back again, the image tends to be right-sided. The largest refracting telescope, which is still in use today, is in Chicago. Considering the lenses are quite cheaply made, they tend to be available at quite a low price. Therefore, the most telescopes people obtain are refracting telescopes. They are good for observing the Moon, Jupiter, or Saturn. Reflecting telescopes, however, do not use lenses. They use mirrors. They have a primary mirror that reflects into a secondary mirror, which focuses into the eye. They can be quite large and may have multiple mirrors which focus into the secondary mirror, which reflects into a person's eye. Considering telescopes are typically utilized to view objects that are very dim, it is desirable to have an objective with as large as a diameter or aperture as possible. In many aspects, a telescope is similar to a microscope. Both use two converging lenses to give a magnified image of an object with a small angular size. In the case of telescopes, the objects are quite small and right at hand. They can be used in laboratories. However, with telescopes, the objects can be quite as large as galaxies and the angular size is quite small due to great distances. Class, you might have thought that the purpose of the telescope is to magnify objects so we can see them better. That's how a lot of telescopes are marketed. But to be honest, that's not the case. Please remember, the purpose of the telescope is to make things easier to see, to make the invisible visible, and to make things already visible more clearly. These formulas can be used to determine the angular size of the image formed by the eyepiece and to find the total angular magnification of the telescope by taking the ratios. Okay class, it seems like you're ready. Now I will give you a question in which you can use the formulas which I previously gave you. Good luck. It states, a telescope has a magnification of 40 and a length of 1,230 millimeters. What are the focal lengths of the objective and eyepiece? We can easily determine the two unknowns, okay? So, the focal length objective and the focal length eyepiece from the two independent bits of information given in the problem statement. Primarily, we know that the magnification is equal to 40 and the total length is equal to 1,230 millimeters. Combining this information gives us the two focal lengths. Primarily, we will use the magnification equation to write the focal length objective in terms of the focal length eyepiece. Then we will substitute that the focal length objective equals 40 focal length eyepiece into the expression for the total length of the telescope. Consecutively, we will divide 1,230 millimeters by 41.0 to find the focal length of the eyepiece. Then, we will multiply the focal length eyepiece by 40 to find the focal length of the... Okay class, as always, the best physics teachers leave the fun part till the end. Thank us later. Now, we will be labeling the basic elements of the telescope. We already labeled the distant object, the objective lens, the image formed by the objective, and now we are labeling the image formed by the eyepiece at infinity. Remember, it is important that we have an image of how the objective and eyepiece lenses work so that an image is formed within the telescope. Now we are labeling the eyepiece, and consecutively we will label the focal length of the eyepiece. Now we will give you a small review and tips to know about telescopes. Okay, so telescopes which are quite longer tend to have a greater magnification. In addition, telescopes with a larger diameter or aperture gather more light and have a greater resolution. And for a refractor, a large aperture means a very large and heavy piece of glass. Class, thank you so much for your time. We hope you enjoyed this lecture, which compared the optical telescopes and radio telescopes. We hope you had a great insight into the components which differentiate each telescope. And if you have any further questions, you all can reach us in class at any time. Thank you. P.S. You all get free telescopes. Thank us later.